This is quite interesting. We're talking about the Parker probe, I believe it is.
Yes.
It was dear old NDGT, I think he's called. When you said the word Neil, I immediately thought of Armstrong. Ah, that's interesting. And then, of course, I realized it wasn't Neil Armstrong at all. It was deGrasse Tyson. And he's not really saying very much there. He's just promoting himself as being so knowledgeable that he can talk about it. But he did make an interesting statement, which I'd never heard before. On the periodic table, what is the element with the highest melting point? And he said it was carbon. And I thought, okay, carbon, well, it may have a high melting point. Why isn't carbon used on heat shield then?
That is a problem, isn't it?
Yeah, it is. Surely if carbon is such a protective material that it can be used to protect this satellite, of course, nobody can go out there and fix it. If it goes wrong, it's too far away. But if carbon is such a high melting point element, which Neil deGrasse Tyson says it is, so it must be true because he's so knowledgeable, why isn't it used on the heat shield of spacecraft? You'd think it would have the same effect, wouldn't you? I don't know. I don't know the answer. Maybe somebody can come up with the answer.
Well, I can at least give you one. Tungsten's known melting and boiling point of all the elements is the highest known melting point is tungsten. And the other one is rhenium. According to Google, as usual, tungsten has the highest melting point.
That's interesting.
I just looked up the melting point of carbon, which is 3,550 degrees Celsius or 6,420 Fahrenheit. And they're approaching the sun at 1,000,000 degrees centigrade. And of course, if they produce a shield like that, why have they never used it for re-entry in Earth's orbit? I mean, simple as that. So if they have such a material that obviously it's a carbon composite of something that they've made up, that they're flying directly at the sun with, if it is that qualitatively good, then why don't they have this material in fire suits for firefighters? Why don't they have boots that you can walk across and inspect the lava flows in Hawaii? I mean, you should be able to walk on lava with this stuff, right? I mean, seriously. And if you notice, Neil, every time he gives a NASA detail out, whatever they've given to him, he just shuts his eyes and drops his head a little bit. When I watch that video, I can just visualize the verbal diarrhea spewing out of his mouth.
According to Uncle Google here, carbon is 100 degrees higher melting point than tungsten. 3,400 for tungsten, 3,500 for carbon. So your question is perfectly valid. Why didn't they make the heat shield out of carbon or tungsten?
Yeah, that's one of the points out there. But when you're talking about something that's going to the sun, they have surpassed that temperature. They claim that this thing can get as close as 5 diameters of the sun from the sun.
But don't forget the other factor, which is the lack of molecules carrying that heat. Yes, on Earth, that would be correct. But if you're near the sun, there's a vacuum. It's the vacuum of space. There's very little molecular components of this solar wind compared to what we get on Earth. So people say it's 1,000,000 degrees or whatever it is, some ridiculous figure. They don't know. That's a guess. It's not somebody who's been that close to the sun with a thermometer that could measure 1,000,000 degrees. No thermometer can measure 1,000,000 degrees. It's just a guess.
It's no different than the Voyager that's been going on forever, and then it reboots itself and re-educates itself and goes to its backup plan and everything else. This is the same fantasy. This is just to promote space travel. That's all it is.
I'm going to send you guys something here. Did we ever take a look at this? This particular astronaut, one click, he has his camera, and then in the next click, the camera is gone. And there's a piece on the ground that magically vanishes as well. Not a space agency sent this to me. He clipped it out of an article.
Oh, my favorite pictures, those. Look at those.
This looks familiar to me. Almost looks like an Owlus article or something.
Yeah, it's from Jack White. That's the one.
What I find interesting about this, is that here we have these two photographs. One is in color, one is in black and white. In the color image, he has his camera, and then in the black and white, the camera vanishes, and then there's a little piece of something there beside the LM leg in the color, and it vanishes in the black and white.
I'm going to pull up the original. It's 8611-863. I got it.
They're actually two separate images.
One's a different magazine.
Yeah. He's further away from the flagpole in the black and white image. It's a similar position, because obviously mannequins don't move. The flagpole is in a slightly different position between the two pictures.
It's the same guy because he has the stripe on his helmet. AS-15 92 12451.
They're saluting exactly, standing beside the flag the same way. But if you look at the color one, there's a whole lot more footprints out behind running around. So they've been moving all over the place. Whether he takes the camera on or off or whatever, I mean, he could change the cue card page or he could do anything. Like if you take a look, one's got an antenna that you can see and the other one isn't up.
Doesn't mean anything.
No, none of that means anything because they're taken at two completely different times. You know, they had to stop for lunch. I mean, Christ's sakes.
Yeah.
This one here, we need some water on the moon. Oh, that's a good one. What's this?
Yeah, he was saying we need some water to keep the dust down. Can you come over and put some water on the set here so we can keep the dust down?
Our thunder's still on, which makes me happy. I tell you, if you could come and sprinkle the whole area with water, get rid of some of this dust.
He does.
Yeah, that's exactly what he said, yeah.
I think what's really going on here is he's just saying this to make a joke.
We don't know. That's
don't
just
know.
some little video clip put together. Could have been done by anybody out there. 50 years later, there's so much technology out there, you can insert anything in a few seconds.
Now, he is also, interestingly, has marked this little thing in yellow. Several cameras identical to the actual Apollo mission cameras were fabricated for environmental testing. Special manufacturing procedures were set up to fabricate the test cameras, and all assembly work was done in a clean room environment. In addition to vibration, humidity, salt spray, and other environmental tests normally performed on space or airborne equipment, the cameras were tested for operation on a simulated lunar surface. Simulation of the lunar surface for both day and night was done in a large vacuum chamber with a solar simulator for lunar day tests. After passing the tests for the mission environments, these cameras were then subjected to more stringent environments to determine the amount of safety margin available. The final tests of the lunar TV camera will be viewed by millions as they watch on their home television sets the exploration of the moon as seen by the Apollo astronauts. Westinghouse Engineer Magazine, March 1968. A solar simulator for lunar day tests? Are you joking?
Well, that must have just been a really big light.
Yeah, a Super Trooper, I think it's called. According to the ABBA song, it was based on the big light they used. I don't know if that's true or not. It makes a good story, doesn't it?
I say, can you imagine the volume and sales of televisions? I mean, when Queen Elizabeth was crowned and the official things were done in the 50s, I mean, the sales of televisions just skyrocketed. And of course, those were all black and white TVs. So you're sitting there with a black and white TV. Now you're going to go out and buy a TV and it's going to be a color TV. For the 1968, 69, I mean, these people would be scrambling like crazy to build enough TVs to sell. They're going to put so much nonsense in there that the original videos that have anomalies in them, like when the guy throws something and you hear it hit, then that'll just, or when he's whacking on something and you hear the hammer strikes, all of that stuff that's real documentation that shows the real fraud is going to go away. And of course, if they start manipulating the photographs, then that lovely wet flag is going to just be, you know,
It'll disappear.
Just be blowing in the wind.
It'll be dried out any day now, won't it?
It could happen. I've been watching for it to dry out.
Yeah,
I mean, after 50 years, you'd think it would dry out.
you would. Yeah. Even if it's on Earth, it would dry out, especially in Arizona.
People really think that of Arizona as a desert. Flagstaff is 7,000 feet elevation, and it very much has the same climate as like Southern Ontario does, or New York, whatever. It snows in the wintertime there. Like, it's going to be interesting because you've got all these countries now, so-called, that are capable of low Earth orbit vehicles, manned. Be interesting to see what they come up with.
Yeah, nobody's gone out beyond the Van Allen radiation belts with humans, have they?
Well, they can't prove it.
Well, they can't do it either because the humans would not probably get back alive. Not easily. I mean, you can send unmanned craft anywhere you like. If they go wrong, then ET will fix it for us.
Well, 2025 is also, you're reaching a maximum in solar flares as well.
That's right, you are. Yeah, it's building up this year. 2024, it was pretty high level of activity. It's going to be even more this year, 2025. It's going to be an interesting year for space travel.
Yeah, maybe Musk can actually get one to space. It doesn't run out of fuel first. He's going to really have to redesign that thing, isn't he? No payload and can't even get there. I mean, that's ridiculous. Can't even make it 50 miles. That's really sad. Somebody should be able to do the math better than that. We have computers that would have calculated that out without wasting all of that money to build the thing in the first place. And all they have to do is grab the Saturn V, take it out of the museums. Maybe they need to build a few more engines. They've already redone, like they have restored the command centers, all of the other stuff so that they can show simulations. They've restored all the spacesuits and everything else. I mean, you just grab them out of the museum. They're going to work. So they set this thing out on the launch pad, fuel it up, and away they go. And that's the only way they're going to prove that they ever went to the moon, is to use the same equipment to show that it works. You can't come up with new stuff and say, oh, we're going to the moon with that, and then claim that you went there in 1969. You have to use that same equipment and the same theory of operation of that equipment.
Well, that's what Artemis is supposed to be, isn't it?
Yeah, and we only need to see it happen once for you to prove it, not 6 times. Because we're going to have onboard cameras, independent cameras on every piece of equipment the whole freaking way.
Yeah, one day somebody's going back to the moon with the right equipment to be able to demonstrate whether humans have ever landed there before they did. I think the next people to land on the moon will be the Chinese.
Once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. From what Arthur Conan Doyle has just said, once you eliminate the impossible, well, let's eliminate the impossible, going to the moon at present with humans. Whatever remains, no matter how improbable, well, what remains? They can't get there.
With humans.
Must be the truth. Well, then there you go. You have the truth. So he's right.
And the same problems exist. The Van Allen belts, the radiation, the vacuum of space.
That has remarkable effects, doesn't it? The vacuum of space, as we're discovering. NASA appear not to take much notice of it. They ignore the effects of the vacuum of space and say it doesn't exist.
Well, because they believe that the topic simply sucks.
Yeah, because if they were honest about vacuum, they would know that a lot of things they claim to have occurred couldn't possibly have happened.
Oh, and another thing about vacuum seals on Apollo. I have another PDF here that Jera sent that goes over the seals, how they sealed all these things and what the seals were made from. So this will be kind of interesting. Now here we have another PDF that's called Apollo Seals, a basis for the crew exploration vehicle seals. Now that's what they used to call the LEM, I believe. Now, however, the CEV seal requirements are different than those from Apollo because of its different mission requirements. So now we're going to take a look at the seals that they used in Apollo and the new crew vehicle that they're using today. This is, of course, supposed to be the one that's going to eventually go to Mars, but they're going to have to get to the moon first.
Yeah, that's a problem.
Page 2, paragraph 2, overview of seals on the Apollo command module. The Apollo command module required seals in several locations, including pressure seals to minimize the loss of cabin atmosphere while in space, and thermal seals to prevent the influx of high enthalpy re-entry gases through gaps in the TPS and into temperature-sensitive regions of the vehicle. Then it goes into this. Figure 1 shows a schematic diagram of the Apollo command module, and reference 2 provides a general overview of the Apollo mission profile and the 3 modules of the Apollo spacecraft. Then, of course, it shows you all the parts, the yaw engine, C-band antenna, the steam vents, the urine pump, the urine dump, and all the rest of the stuff on here. But I would like to find, though, where it said anything about what these seals were made from. Then I go and I take a look at description of the Apollo command module heat shield. And of course it goes into subparagraph B, description of the Apollo command module heat shield. Then we go, okay, it's honeycomb, this, that, and the other, and it's protecting the capsule during re-entry, filled with the epoxy and all that stuff. But where are the parts where it shows the rubber? And then, of course, we looked at the window already.
Flubber.
They have the RTV material. On page 9, they show the RTV material that has been inserted into this adapting cup here.
So were they using flubber the same as Disney did? So the entire document doesn't talk about the compounds of the seals, even though the whole thing is about the seals.
Of course, it goes over Skylab and goes over a few of these missions here. Again, RTV sealed aluminum joint inside of the Apollo Skylab 3 forward tunnel on page 18. So what they're doing is they're working this all up to this new Mars landing probe.
Yeah.
Again, they have to get to the moon first. Well, you know, it shows you everything here. It shows the probes, the drogues, it shows the seals, but it never shows you what they're made out of.
You're meant to assume that they're made of rubber.
Yes, and then if you look on page 23, it'll say thermal seal in the little picture on figure 24, page 23. Well, there's the rubber seal. It says thermal seal. You tell me how that's going to work in torr 10 to the minus 12? It's rubber. It's RTV. It says RTV. The elastomer gasket can be seen in the photograph of the Apollo Skylab 3 forward tunnel in figure 25. When the outboard side of the hatch was exposed to the vacuum conditions, e.g., the command module was not docked to the lunar module, the pressure differential across the hatch served to provide positive engagement of the knife edge into the elastomer gasket and therefore improved the performance of the seal. So they're actually saying that this little pressure differential across the hatch, it helped the seal.
Now, on page 8, paragraph C for Charlie, seals for the thermal protection system of the Apollo command module. It goes into a bit of detail about the RCS, the reaction control system. And then it says most of the thermal seals used on the Apollo command module were composed of high temperature silicons, including room temperature vulcanized silicons. High temperature silicons exhibit ablative properties at temperatures exceeding their maximum use temperatures, i.e. they will burn off, which is what ablative materials do. But that's not going to help very much in a seal if it burns off or disappears or gets ablated, whatever the word is. Now, as described in the following sections, inspections of the seals on the Apollo Skylab 3 capsule revealed evidence of ablation, particularly for seals in high temperature regions of the aft heat shield and the aft shield to crew compartment heat shield interface gap. Oh, so it all disappears. So they're not very good seals, are they?
No, I think they were using faculite. You know, there's lots of materials made out of bakelite. Well, this is faculite.
Nice one.
That, or they could have been using Disney's flubber, because that would help them lift off as well.
And here we have another problem. The outer circumference of a tension tie bolt was sealed with RTG, silicon, to prevent the ingestion of high enthalpy re-entry gases, and a layer of marionite insulation prevented excess thermal conduction from the tension tie bolt to the surrounding stainless steel substructure, Prior to re-entry, explosive bolts were used to break the tension tie bolts and separate the service module from the command module. Well, it's a good thing they went off at the same time.
I don't believe that they had high temperature silicones in the 1960s, not like they do today. Not anywhere close to the temperatures today that they can do silicones with. I mean, that's nice little mix that they can just pop that in there.
Oh, here we have the compression pads. After they have fired those explosive bolts to separate the command module from the service module, they say here, during re-entry, the exposed tips of the tension tie bolts melted flush with the surrounding fiberglass pads, while the temperature measurements at the bases of the bolts showed no significant responses. Temperature didn't conduct down the bolts, which is a bit odd. One of the compression pads can be seen on the Apollo 11 command module, shown in Fig 7. Although it appears that the molten tension tie bolt was removed after recovery of the vehicle as part of the post-mission inspection of the heat shield. Well, that's not what's appearing on the Artemis program heat shield. They have compression pads. They don't show how they're put in place.
Well, it's interesting how something can melt and not absorb heat at the same time.
Yeah, it is.
And not conduct heat. That's argument in itself.
I think they're exposing themselves here.
I am just noticing in here the windows all of a sudden have become aluminum silicate panes. So what they're talking about is the window glass is transparent aluminum. Right from Star Trek, The Voyage Home, where they need to have transparent aluminum to keep the whales in. This is what the window glass on page 27 here. The panes are now made of inner aluminum silicate. That's transparent aluminum.
Reinforced silicon, outer silica pane, a blatter.
Yeah, well, window glass was window glass in the 60s. They didn't have that type of strength. It is possible to make transparent aluminum, by the way.
I believe they have a form of it, but not to be used in real-world applications.
I think they were working on it for bulletproof glass, is it not? And then they laminated it as well. It's nice that they have updated the Apollo windows, because I have the original documents on this and there was nothing like that.
Why are they using silicone for these gaps in the heat shield?
They
Figure
have
12.
a magnesium fluoride coating on the inside with a blue-red coating to block both infrared and ultraviolet and solar radiation. Boy, have they ever upgraded these window panes, because that is not anywhere in the original documents. And I have plenty of documents on the windows. If they're getting rid of all of this radiation through these windows, because how many times have I said, yeah, but they got windows, right? They're talking about the radiation. This is what they have done. This is how they update their files, because the original documents with the windows do not state anything about coatings on the windows. And as a matter of fact, they didn't put coatings on windows into the 1980s before they started coating windows for office buildings and stuff. And then you go down to the next one, and now they've got new seals on the windows as well. 511 coating.
RTV 560 seals on the pressure window. Fiberglass insulator RTV 511 containing some damage to the RTV 511 is evident. So why did it break down?
Why was there water running down the inside between the panes in the pictures?
Yeah.
Why did they have a rain guard on the windows? Because it was sitting outside at Flagstaff. It's the same bloody command module that was inside in 1964 in Houston in the vacuum chamber, and it split the window and it split the walls on it when they were pressurizing and depressurizing it in there. And they used that same piece of equipment outside for simulation. And that's where you see that the rain is coming in the thing. You can see rust on the inside of that vehicle as well. And they put that rain guard on there. And of course, when they moved it around, it broke it because they're using the straps. It comes right up over the straps. And they just left it outside. But the documentation from 1964 on the vacuum testing of that particular machine was there. This is all new Windows stuff. I've never seen this kind of shit.
On this paragraph here, atmospheric reentry at the conclusions of the manned missions to Mars will generate temperatures exceeding those generated during the lunar returns. However, the LEO reentry environment will still generate high thermal loads and heat fluxes on the vehicle thermal protection system. Jarrah said that the CEV was what they used to call the lunar module.
That's right, yeah. The Crew Exploration Vehicle is currently being designed by NASA, the United States' newest manned space vehicle, to replace the space shuttle for missions to low Earth orbit and to enable long-duration exploration missions to the Moon and to Mars.
I thought they already been to the moon.
No, don't puncture the dream.
This is what NASA has done to back it up. They made this look very 1972, but this is not a 1972 document because the case copy file was never printed like that. It was stamped on and it was always on the angle. And the text is completely different on this document than anything else. And I've looked at all of the documents for silicones and everything else, all of their PDF files. I've never seen this one before in my life.
Look at the dates at the bottom. You have 1973, 1974, 1968. So yeah, you're right, 74.
Yeah, but they're saying like this goes with the other PDF file for this 560, which didn't exist because I've read everything on silicones from Joyce Deaver's testing of every damn kind of adhesive out there. This was never in there. And they didn't have silicones that would run over 800 degrees in the 1960s. This document, this has been generated for the purpose of us to look at and dispute our findings.
Yeah, that's newer font.
Everything's new about it. The other ones were copied, they're blurred, they're smeared, they're everything. None of that is here. The case copy file was always put in a stamp.
Yeah, no stamp here.
Yeah, and when you look at these charts that are sideways and stuff, you could hardly read them on any of the other documents. And the graphs, you could hardly read them. These are clear. This entire document is just about RTV 560, which still doesn't work in that kind of a vacuum anyway. So, because you still can't have silicone seals out there. I mean, they try really hard. They're sitting there with their $20 billion a year with a whole team of guys to sit there and write these articles up and provide them and make them look like they're supposed to be old. Well, they got to do a better job of making them look old, number one. And second of all, there isn't another document out there, the original documents, that discuss this type of silicone.
It is interesting, though, how they still have that thermal seal. It's still rubber, it's still RTV that is actually sealing that hatch. Once you take the drogue out and you pull the hatch down and twist it and seal it. So now guess what? We were wondering what that seal was, and this document just showed what it is. It's made out of RTV.
Just stomp on that a few times when you're coming in and out the door and see how well it seals. They really like to push their bullshit out. When they come up with stuff like this and it's so obvious to see it, and they think nobody else has researched any of this stuff, and to come up with this crap and write an article here and an article there and then say, oh, it's good. But they don't realize that this stuff doesn't work in that vacuum either.
Well, again, we go back to what Joyce Deaver did with those experiments in her vacuum chambers, and look what this stuff does. It just swells. So if this stuff goes into space and it starts to swell, then how are you going to get that hatch open if it's closed? And vice versa, how are you going to open it if it's sealed itself in there and has expanded? You're not getting it open. So for the Apollo 6 command module, they have the RTV around the door itself. On these other ones, the gasket, the RTV, is actually in the door frame.
Yeah, you're not going to get a seal unless you actually bolt the thing shut because the pressure's on the inside as well. When you look at any of the vacuum chambers and they get multiple bolts and they're torqued down against that seal to compress it. The vacuum's on the inside, so the vacuum's helping keep that lid shut as well. And they're still having to tighten it down so much so you don't get a leak coming in. Imagine if the pressure's on the outside trying to push the lid off and you're trying to do it. You're going to have to bolt that down. It has to be absolutely super clean, and it has to have the proper tension on it. It has to have the pressure torque on those nuts to hold it shut. Imagine re-entry. The expansion on the aluminum shell itself is going to distort enough. You're going to break the seal. And that's going to be the same as if you're on the lunar surface. You're in the sunlight, you're not in the sunlight. The thing's going to shrink on one side and expand on the other. Here's one for NASA. Now that you have upgraded the windows on the Lamb and the CSM, you've upgraded these windows to block all that stuff now. Let's see the documents you put out for the freaking helmets, because the glass in there and the shielding and all of the stuff. Where's the composition of that material? That material.